All right, hello there, boys and girls. Today we are on lesson 77, converting units of weight and mass. So let's go ahead and get started. Make sure you put lesson 77 notes up on the top of your paper and the date so that you remember when you're turning it in, and we will get going. Remember, you can pause this video at any time if you need more time to work on something. Okay, so here is your power up mental math. Let's work this out. A through H down the side of your paper. Okay, so take your time and go through those. A says, what is the time 2 hours and 15 minutes after 7:45 a.m.? Okay, so you need to take 7:45 a.m. and you need to add 2 hours and 15 minutes to it, and that will give you your answer. All right, so 2 hours and 15 minutes after 7:45 a.m. Letter B, 100 divided by 4. Letter C, 1,000 divided by 4. D, what is the area of a square that has 5 inches on each side? Remember, to find the area, you need to know the length times the width. Brian, letter E, Brian had $10 and he spent $6.80 on football collector cards. How much money did Brian have left? So you need to subtract there to find the answer. Make sure to put your decimal points and your money sign. Letter F, 50% of $51, so you need to divide that. Letter G, the square table was 99 centimeters on each side. What is the perimeter of the table? So you need to add 99 times 4, or 99 times 4 to get the perimeter. You're going to add each side. And letter H, the square root of 49 times 5 minus 10 divided by 5 minus 5. All right. When you're finished, go ahead and keep on moving. We're going to go down here to our problem solving. Casey built this rectangular prism with 1-inch cubes. How many 1-inch cubes did Casey use? Explain how you arrived at your answer. All right, so you need to do some work here to figure out how many 1-inch cubes Casey used. Let's look at this together. What information are we given? Well, we know that we can measure, we're given a diagram with dimensions, and we're told that the figure is a rectangular prism. So that's the information that we have. It's a rectangular prism. What are the different dimensions that could be measured when we look at the rectangular prism? Well, we could measure how many cubes high, that's the height, how many cubes across to get the length, and how many cubes deep to get the width or the depth. And what are we asked to do? We're asked to determine how many cubes Casey used to build the prism. So we need to make a plan. What kind of problem-solving strategies could we use? Well, today we're going to use that we can make the problem simpler by considering each of the 2 layers of the cubes. We could write an equation to help us find how many cubes are in each layer. Okay, so we have 2 layers there. We have the bottom layer and the top layer. And so dividing those into 2 layers instead of keeping it all together will make it simpler for us to figure out how many cubes are in this rectangular prism that Casey built. First, we see 16 cubes were placed in 4 rows of 4 to form the bottom layer. And then secondly, we see 16 cubes were placed in 4 rows of 4 to form the top layer. So how many cubes were used to build the rectangular prism? Well, there are 2 layers of 16 cubes each, so you could write the equation 2 times 16, and you would get the answer 32 cubes. Remember, the last step when we're doing problem solving is to check our work. Did we find the answer to the question that was asked? Yes, we did. 32 1-inch cubes were used to build the rectangular prism. We wrote an equation to help us find the total number of cubes, or at least I hope you did, 2 times 16 to get 32 cubes. We can actually see only 23 cubes in the diagram. The other 9 cubes are covered by the cubes on top and in front of them. All right, so we can use the formula length times width times height. In this case, the formula gives us 4 times 4 times 2 equals 32. All right, so that's how we figure that out. Today's new concept. We're talking about weight and mass. We're talking about weight in the U.S. customary system, which includes ounces, pounds, and tons. And there's the abbreviations. You might want to note those down if you don't know them already. Ounces, OZ, period. Pounds, LB, for whatever reason, period. And tons is TN, period. And then we're talking about mass in the metric system, which includes milligrams, MM, grams, with a small g, kilograms, which is a small kg, and metric tons, which is just a t by itself. All right, so you might want to take those down in your notes. We're going to look at this chart. You can also find this chart, I believe, in your book. Let me see what page that's on for you. Yeah, this chart is in your book on your page 70, no, less than 77, your page 499 if you want to look at your book to see this chart. You don't need to copy it into your notes. You can look at it on your own time on page 499 in your math book. Okay, here we see 16 ounces is equal to 1 pound, and 2,000 pounds is equal to 1 ton. Okay, that's the U.S. customary system. Then that's the measurement of weight system in the United States. In the metric system, on the right-hand side of the chart, we see 1,000 milligrams equals 1 gram. 1,000 grams equals 1 kilogram. And 1 kilogram equals 1,000 kilograms equals 1 ton. On Earth, a kilogram is about 2.2 pounds, and a metric ton is about 2,200 pounds. It is not exact, but it is about that. Okay, that's a good reference point. Why would we say on Earth? On Earth, a kilogram is about 2.2 pounds, and a metric ton is about 2,200 pounds. Anybody know why? If you can think of why, write it down in your notes, why that would be on Earth. All right. Example 1. A large elephant weighs about 4 tons. Ooh, 4 tons. About how many pounds does a large elephant weigh? All right, so he weighs 4 tons. So we can then figure out that 1 ton is 2,000 pounds, right? We know 1 ton is 2,000 pounds, so 4 tons is 4 times 2,000 pounds. 4 times 2,000 pounds. So a large elephant then weighs how many pounds? You need to do the equation and you would get 8,000 pounds. A large elephant weighs 4 tons or about 8,000 pounds. All right. Good. So you should just write that out as an equation on your paper. Example 2. Boyd's watermelon has a mass of, okay, a mass. So we're in the metric system. And you see kilograms here. Okay, Boyd's watermelon has a mass of 6 kilograms. The mass of the watermelon was how many grams? Okay, you can go back to the chart again to help you figure this out. 1 kilogram is equal to 1,000 grams. So we need to do 1 times 6, which would give us what? Or sorry, 1,000 grams. 6 times 1,000. So the watermelon weighs 6,000 grams. Okay, so if it weighs 6 kilograms, it weighs 6,000 grams. So we got one heavy watermelon there. Okay. Example 3. Anton works at a sandwich shop, and he uses just 2 ounces of cheese for 1 sandwich. If he makes 16 sandwiches, how many pounds of cheese does he use? Well, Anton works at a sandwich shop, and if 1 sandwich uses 2 ounces of cheese, 16 sandwiches would use 2 times 16. So you're going to write 2 times 16 to figure out how many ounces, right? How many ounces of cheese were used. And 2 times 16 is going to get you 32 ounces. 32 ounces of cheese. And then it says how many pounds does he use. So then you need to convert it and say that 16 ounces, right here, this 16 ounces is the same as 1 pound. And 32 ounces is times 2. So then we know that he used 2 pounds. And remember the symbol for pounds is LB. 2 pounds of cheese. 2 pounds of cheese for the 16 sandwiches. Now it sounds like a lot of cheese. All right. Example 4. Mr. Harrison's truck has a cargo capacity of about a half a metric ton. He has 3 containers weighing 156 grams, kilograms, 127 kilograms, and 149 kilograms. Will the weight of the containers overload the truck? This one's a little bit more complicated. We need to break it down a little bit, right? So we know that he can hold a half a metric ton. And we estimate the total by using compatible numbers, right? We don't need to get exact, but we need to estimate. So we know we have 150 kilograms right here. We're going to estimate to be 150. Then we're going to say 125 because that's pretty close, and then 150 again. Okay, and if we add those all together, we would get 425 kilograms, kg. Okay, remember it's always important to remind us what kind of measurement we're using so we don't get confused. All right, if a half a metric ton is 500 kilograms, then is it going to overload it or not? Is it going to be okay? Well, 425 is under 500, so it's okay, right? The containers will not overload. Yay! All right. All right, lesson practice. 1/2 pound, sorry, 1/2 of a pound is about how many ounces? 1/2 of a pound is how many ounces is what that should say. Well, if a pound is 16 ounces, remember from before? So half of a pound would be 8 ounces. Okay, 8 ounces. OZ. If a pair of tennis shoes is about 1 kilogram, then 1 tennis shoe is about how many grams? If a pair of tennis shoes is 1 kilogram, then 1 tennis shoe is about how many grams? You're going to need to go back and look at your chart to figure that out, but I will give it to you this time. 500 would be the answer for letter B. 500 grams. All right, these ones you're going to do on your own. 10 pounds of potatoes weighs how many ounces? You're going to need to use your chart and do some math. 10 pounds of potatoes weighs how many ounces? Letter D, 16 tons is about how many pounds? 16 tons is about how many pounds? And letter E, a fabric store manager placed an order to buy 9 rolls of ribbon. Each roll weighs 425 grams. Use compatible numbers to estimate. Okay, there's your clue. You're going to estimate with compatible numbers. Okay, you don't need to find an exact answer. The total weight of 9 rolls of ribbons in kilograms. Okay, so you're going to need to show your equation there on letter E. How do you figure that out? All right, that is our class. So homework today is pages 500 to 502. You're going to do even numbers only, starting with number 2 to number 30. Even numbers only. Have a fantastic day, and I will see you in class. Bye.